If scheme had only numbers and two argument procedures, parentheses would be unnecessary. To demonstrate, implement tally, which takes the list of atoms in the scheme expression. It returns a list whose first element is the value of the original expression. Assume that the original expression consists only of numbers and call expressions with arithmetic operations and exactly two operands. I think that this question requires the most holistic thinking of the function and the one that really tests your trust of recursion. Hopefully with the doc tests, you can understand what tally is supposed to do. Be sure you read this question carefully and understand that we're always going to pass in linked lists and return linked lists. Okay, here's the skeleton code. Our first case is if the first element of our linked list is a number. We could do something like cons car of s, but for one, you might notice that in these exams, if they want you to construct a linked list, they'll typically be explicit about it, like down here. And with base cases, in general, returning something like s is usually the best move. We've taken care of the base case, and now onto the recursive case. Before we move on, I should mention that it's important to note that we return the whole linked list, because it'll be important later on. Something to realize about this recursive case is that it's if the first element of the linked list is some operator. Let's analyze the code to see what's immediately apparent. So car of s here is going to be some operator, and if this here is an operator, what if the car of first and second, whatever they were numbers? It's not too much of a stretch here, is it? For now, let's assume that we have an operator and two numbers. If we have an operator and two numbers, we can evaluate it with eval, but this implementation isn't quite correct. The way eval works is that it takes in a linked list. So if we have a sequence of an operator and two numbers, we need to put them in a list first, and then evaluate that list. Luckily, we have space to do that. So if our implementation of tally is eventually correct, this line is done. Let's look at some other spots of our code. Let's look at this code here. Car of first and car of second we said are numbers, but this also implies that first and second are linked lists. Let's try and figure out what first and second are, and also let's remember that we haven't made any recursive calls yet, and since this is the recursive case, we'll be dealing with the cutter of s. The car of the cutter of s can be two things, an operator or a number. We need a way to deal with both operators and numbers. This should be a hint to call tally on cutter of s, and this will properly evaluate the cutter of s, regardless of whatever catter is, so that the car of first here will be correct. For the next part, I think it's easiest to talk about these two lines at once. The key realization here, I think, is to realize that the base case here evaluates a number and leaves everything else untouched. And so we need our recursive case to do the same. If we have something like this, when we evaluate this, we'll need to keep this part separate. We pass this list into our function, and since the first element is an operator, we go straight into the recursive case. First is the tallied version of this, so we'll go into the function again, with an operator as the first element. We tally this to be first, and since the first element is a number, we go into the base case, so first will still be this. Now how can we assign second to 2 to properly evaluate this? We could say cutter of the cutter of s, but remember that this here doesn't have to be a number. It could be an operator. We need a way to deal with both operators and numbers. This should be a hint to call tally on the cutter of first. So we'll be returning back to our original frame. We see that first is a linked list with 3 at the front. But what's the rest of first, and how can we use it to make second in this frame work? Let's go back to where we just were. Notice that second is this. We'll need to return this +3, 4 to deem it as a second in the parent. So in general, the linked list we'll be returning is going to be the cutter of second. Back in the parent, the cutter of first is going to be +3, 4. This all evaluates and it works out. It looks like everything is filled out and we're done. Before we move on, I want to say that these exams don't just test your CS abilities, but also your ability to take 61A exams. Since you're at Berkeley, you're probably pretty good at taking standardized tests. Those skills, especially for questions like these, come in handy, be it for recognizing patterns like how base cases usually work or implementation of recursion, or a certain line of logical thinking that makes answering the questions much easier.